All right. What is the fourth term of the binomial expansion x plus 1 to the 6th power? Okay, I'll tell you what. Mr. Dalday is really good at this. Watch. What is a plus b squared? In the previous problem, I had to do that exact answer, and so let me just scroll up to show you. That would be
a squared plus 2ab plus b squared.
Are we cool with that? You guys know how to FOIL that, right? All right.
So now the next question I would have is, what is a plus b cubed? Okay? Well, what you would do is you would take this thing right here, the previous answer, and multiply him by a plus b.
Does that make sense? And then you would distribute in this
A to everything in here, and distribute in the b to everything in there, and then add them all up, and you would get some answer. I'll tell you the answer, because I memorized it. Actually, I didn't memorize it, but there's a trick.
a cubed plus
3ab squared plus 3a squared b plus b cubed.
If you don't believe me, and I suspect that you don't, multiply it all out and see what you get. Let me show you the next one.
What is a plus b to the 4th power? Okay, let's see. That is a4.
Actually, you know what? Let's not believe me. Let's go to Wolfram Alpha and see what they say. Wolfram Alpha. Now, you won't have Wolfram Alpha on your test, so don't rely on this thing, but I'm just showing you. Let's see. What is a plus b to the 4th power? Okay, and before I get the answer, I'm just going to
tell you what I think it is. It's a4 plus 4a b cubed plus 6a squared b squared plus 4ab cubed plus b to the 4th power. Tell you what.
Let's go to Wolfram Alpha.
And let's check.
Come on, Wolfram Alpha, tell me the answer. All right, here we go. Here's the answer. Here's the answer. It's right here. Got it. A4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b4. Yes, I am amazing. I'm going to do the next one.
X plus b 4th power or to the 5th power. That's a5 plus 5ab4 plus 10a squared b cubed plus 10a wait, no. I messed this up. There should be a 3 right here, and then this one should be 4. Let's see. This would be a cubed. Let's see. Let me just erase this a little bit. Hold on. 1 second. I'm almost amazing. I'm being sloppy because I'm trying to be fast. And that's making me be sloppy. This is 5a4b plus 10a cubed b squared plus 10a squared b cubed plus 5a b4 plus b5. I'll do one more. A plus b to the 6th power. That is a6 plus 6a 5b plus 15a 4b squared plus 20a cubed b cubed plus 15a squared b4 plus 6a b5 plus b6.
And if you don't believe me, which I would suspect that you don't, Let's see what Mr. Alpha has to say about it, or Mr. Wolfram has to say about it. Look, I got the same exact answer that he got. Now, come on. Come on, you guys. Pet my ego and tell me that I'm amazing. Say, wow, Mr. Dalton, that's amazing. How did you do that? Yeah, yeah. Yeah, because that's what I'm looking for. That's what I want from you. Ha ha ha. Because I'm amazing. Look at how amazing I am. Okay. I'll tell you. There's this dude named Pascal. His name is Blaise Pascal. It's one of my favorite. He is actually my favorite mathematician of all time. I like him the best. I know. You guys are thinking, wow, most people have like sports people as their heroes. Blaise Pascal is one of your heroes? You're such a nerd, Mr. Dalde. Also, Johannes Sebastian Bach is one of my heroes. Both those guys, super awesome in my book. Anyway, here's what he kind of came up with. What he wanted to do was he wanted to find a pattern of the coefficients. That's the numbers in front of here. Of each of these things. Got it? So, what he did was he wrote them down. I'll write them down for you. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. And that's just the first 6 of them. See, I just took these numbers 1, 2, 1, and I plugged it right here. 1, 2, 1. 1, 3, 3, 1, that's right here. Does anyone, do you guys understand what's going on here? Alright, now here's the next question. Can you see the pattern? I'll give you a few seconds to look at it because you guys got to leave at 11 o'clock and I don't have a whole lot of time. You do see the pattern. Okay. The next set is going to be 1, 7. What's the next number? Take a guess. Or say IDK. I love you just the same. It's fine. 21. Awesome. 21, 35, 35, 21, 7, and 1. Awesome. Sam, you see it. You get this number on the bottom by adding up the two numbers that are next to, above it. So it makes this kind of Christmas tree looking thing. Have you seen this before? All right. But I bet you didn't know that that's what it was used for. It was actually used for this binomial expansion. You've seen the trick before. But did someone explain to you that that's the actual use for it? Now, if I did, I would have to shake the hand of your Algebra 1 teacher. Anyway, that's what it's used for. So I suppose that if you wanted to do this x plus 1 to the 6th power, you could do this. X plus 1 times x plus 1. Figure out what that answer is, then multiply that answer by x plus 1. Then multiply that answer by x plus 1. Then multiply that answer by x plus 1. And then multiply that answer by x plus 1. And then once you get to that, you look for the one that has an x4 in front of it, and then you figure out what the number is in front of that. That's a horrible, horrible day for all humanity. But what I would do is I would say, okay, well, let's see. X plus 1 to the 6th power, this is going to be my coefficients. 1, 6, 15, 20, 15, 6, and 1. See, I'll show you right here. And in this case, my A is the same as X. So this would be, and my B is 1. So this would be X6 plus 6
x to the fifth power times 1. But I don't even need to write the b's down because 1 squared, 1 cubed, 1 to the fourth power, they're all the same number.
It's just 1, and when you multiply
Multiply by 1, you don't even need to write it down. So I have 15 x to the fourth power plus 20x cubed plus 15x squared plus plus 6x plus the number 1. That's what would happen if I'm using a as x and b as 1. Now, what is the number in front of the fourth x to the fourth power?
$15. Exactly. So what's my answer here? 15. That's it. How would you do this any other way? There is an equation, and you know what? I'm not going to teach you that equation because I think that that would confuse you more. So what I'm going to do is I'm just going to leave it like that. The two ways you can do this is you can do this the extremely painfully slow way, or use this Pascal's triangle trick. The key here, though, is I'm sure there's not a whole lot of students who've seen this trick before. But now you have, and it's cool. Don't forget it.